Okay, so we're the World Trade Team and we made an ingredient detector. So our team consists of me, Neev, Ishaan, Tommy, Sai, and Peter. And our mentor is Rinav. Our goal is we wanted to create an image classifier that predicts what ingredients are in a picture of a meal.
So let's take a look at the website. So this is the website that has been hard-coded from HTML, CSS, and JavaScript. We didn't use Figma or anything, any ready-made templates. Took a lot of time, but I think it came out pretty well. So this is just the basic description. It's an image classifier that predicts what ingredients are in the image. And we can actually try it out. So if I were to upload this picture of what seems like a fish, it actually predicts correctly minced green onion, pepper powder, pork slices. Now that's a little bit of inconsistency there, but it did predict the fish. And since fish and chicken and all these kinds of foods have similar textures, that's how it predicted it. And this is the different views that the AI generated through noising the image. And then we also have a description about what we did with the data, which we will talk about later in our presentation. And then we have a small little profile view. I will say this website, once it's live, will have it has a lot of Easter eggs, so feel free to explore.
We had a few motivations going into this project. So like we've seen foods that we're not familiar with across the world. And when we see these foods, many of us wonder like what's in there, how do you make it? And like, well, what am I looking at? So the general public, they will look at this and maybe like use this model to make their own version of the dish they're looking at. But for other people, it can get very important to know what's inside of a dish. And we have a story about that.
Yeah. So a personal anecdote related to the motivation is when I was in the southernmost province of China, Yunnan. Given my food allergies and limited Mandarin speaking skills, ordering food and asking about ingredients wasn't exactly easy. Our project aims at solving this problem as well as providing the opportunity to create the dish yourself.
So yeah, as provided by the example, knowing the ingredients is really important for people who have food restrictions like vegetarians and or like allergies. So this model allows them to know what's in the food they want to try and then make sure that it's safe for them to eat it.
So a little bit about the process, how we made this application. So the first week we spent learning about data types, and we actually created our own custom kind of data type by using concepts such as hashing, hash maps, and hash tables. The first week was a lot of learning. The second week we learned how to interpret large amounts of data because data sets are huge. Like, not talking 1 gigabyte, we're talking hundreds of gigabytes at times. So we use pandas to create data frames, learn how pandas works, and we have to make sense of this huge amount of data that's given to us because data is only as good as what you can understand from it.
Yeah, the next part, so model design was devising model architecture using PyTorch, an open source machine learning framework. The last step in the data pipeline was training the model using training data. So looking at algorithm training and evaluation, the first step involved creating the model from scratch. So we actually created our own model. So our team based it on the popular VGG16 architecture for image classification. Step 2 involved training the model using Vario's 172 datasets training data. The final step entailed evaluating the model predictions on the testing data. We used precision and recall as performance metrics.
you might have noticed that we do a lot more with our AI than just predict the ingredients. We also generate images. To make the encoder decoder system, we retrained our model and added extra layers that, in a simple sense, they just undid what the encoder, the part of the model that guesses the ingredients, did. This allowed it to extrapolate the output of the encoder and decode them into a recreation of the original image. The loss we measured was MSE loss, which was pretty much the mean squared error between each element in the input X and target Y. So basically comparing the image we got and the image we started with, the pixel values. We trained over the same set as our encoder, but our results didn't turn out super great. So Rinav trained again for us, and that's what you see on the website. It gives better results, but it's not fantastic yet. So we're still working on possibly making it better.
Awesome. Now I'll briefly talk about the VGG architecture used for our convolutional neural network, or CNN. So a CNN is a multi-layer neural network meant to recognize visual patterns from pixel images. Using convolution and max pooling layers, the network reduces spatial dimensionality and increases the number of channels. This can be seen in the VGG net figure above. The reduction in image dimensions, so 224 by 224 to 112 to 56 and so on. And the increase in channels, so 3 representing RGB to 64 to 128 and so on. This allows the model to create more features in the neural net, representing different patterns to later classify accordingly.
Obviously, we faced a lot of challenges, as did all the other groups, when coming up with our model, but we had 3 main challenges over the process. The first was the training duration, because naturally we had a lot of data, so it took 3.5 hours to train our model, and then even longer for a more complicated model that we didn't end up using, but it took a lot of time in general. Our second problem was our GPU server load. CoCalc is a really great software, but it was down quite a bit, so we had a lot of trouble on some days even being able to test at all. So we had to go back to our CPU server, and there we could just kind of run like little tidbits of code, but we couldn't actually train the model till the GPU server was back up. And finally, our data set changes. You might have noticed that we kind of specified to East Asian food. The reason that is because our original data set had over 1 million images, but it was frankly unusable and our model was not training well. So we had to find something a little more niche and a little better, like kind of formatted in terms of the labels. So we found one with 110,000 images. It was specific to East Asian food though. So that was kind of what led us there. But in the end, we did get a pretty solid model. So in terms of lesson learned, we learned 3 main lessons. The first is teamwork. During the project, we learned how to compromise and help each other. Coding by yourself is very different from coding in a group, and you have to work out how do 2 people work in the same code file and still get stuff done without messing each other up. How do you split up the work? And in general, we just learned a lot about teamwork. Secondly, we also learned a lot of new coding techniques, learning how to handle matrices, inheritance, large amounts of data, like very large amounts of data. How do you like go over all of that efficiently and be able to make a model? And finally, for future planning, Rinav was our instructor as well as our TA. So his presentations throughout the program gave us amazing insight on professionalism and a high-level overview of AI, and just kind of how do we take this to the next step, and not just this project, but what is AI in general, so we can work on the next project, perhaps by ourselves or with a different group.